Welcome to the third video of the SMART tutorial. So in the last video, we went over the pipeline setup. Now we're going to go through the alignment across the anterior-posterior axis. So I'll just pull up some figures really quick to explain this part. So in the last video, in the setup PL function, we manually aligned the first and the last usable image in our data sets to the atlas plates. And we also specified a series of internal reference plate coordinates that we're going to align using the choice game now. So you don't have to manually scroll through your entire data set to align these plates anymore. And then after you manually align these plates, you'll be presented with the midpoint images as a qualitative check, along with the atlas plates that correspond to those midpoints. And so we can see, we can check whether the alignment of these internal plates are good. So alignment of these plates is done by presenting these three options, where the middle option is SMART's best guess based on the first and last plates of which image corresponds best to the atlas plate. And this atlas plate will automatically pop up, and it'll correspond to the coordinates, the internal coordinates that we set in the setup PL function. And then the left and right choices are anterior and posterior choices. And the anterior and posterior choices will start out as really clear, obvious choices, where it'll be 200 Z steps anterior and 200 Z steps posterior. And then you choose which of these is the best. Here, you would clearly choose the middle choice. And then if you choose the middle choice, the anterior and posterior choice will progressively zoom in. So it'll be 100 Z steps to the left and 100 Z steps to the right, until the choices become so similar that they're basically identical, the images to the left and right. And at that point, the margin of error is so small that you would basically loop onto the next atlas plate. And so this choice step is actually user modifiable, but the default, I believe, is 200, 130, and then 10. So after these are aligned, you play the midpoint check. So that's explained right here, just the image that SMART guesses as the best image to match to the midpoint atlas template pops up. And you would just say, okay, does it look alike, yes or no? And if you're not satisfied with it, then that one midpoint plate, or however many that don't align, will be used again as another internal reference plate. So let's get started with playing the choice game and demonstrating based on the coordinates that we've defined over here. So actually, let me first click on the choice function. And so, yeah, it's a smart idea to always look at the help page, so you can see the usage. So you can see the only argument that's required is the setup argument. And let's go to see what the output value is. So yeah, we want to return this also to the setup variable. So let's first run this function. Setup. Let me first comment this. Play choice game. All right. All right. So we're going to run the choice function. And you can see that there's a bunch of default variables here. I want to point out this one. This one's midpoint. Midpoint is automatically set to equal false because we want to first play the choice game and loop through these plates first. But once you want to play the midpoint game, you would set the midpoint variable, the midpoint argument, to true. So let's just run it as is right now. All of the defaults are explained down here. For example, you can set the choice steps over here if you want, but we'll take the default. One more argument that I'd like to mention is this xpos argument right here. So you can specify in a vector of integers the actual x position of the three choice windows that pop up. And this is designed for if you have a dual monitor setup. It pops up really nicely on high resolution dual monitor, but because I'm using a laptop right now, I've actually manually specified which X position works best for my monitor. So if the three windows aren't popping up in a nice spacing on your monitor, you can go ahead and set that up right now. So I just did that just to accommodate my setup. And so let's run this. Okay, so you can see my three choice windows now pop up nice and evenly on my screen. And something you'll also notice is the Atlas plate automatically pops up. So if I were to, I'm just going to make this a little smaller. If I were to compare, you can see that obviously the very first choice, it's very clear that the middle image works best in this choice game. So once you pick the middle choice, that's when the options get progressively closer. So you can see that the difference between them is now 100. So something that will also help you is if this plate is not enough, you can go ahead and pull up that PowerPoint, that qualitative PowerPoint that I mentioned earlier, where we already aligned an example data set. So that'll actually help you out, where you can actually look at the autofluorescence channel and take a look at how we've aligned things to these templates. So that might help you guys out a little bit. So you can see that we're on Atlas plate 1.91 and right? And you can see that we want it to look like this. So let's go ahead and match that up. So I will say, I still think that choice 2 looks the best, so let's enter choice 2. And it'll get a little harder every time. So let's just go ahead and play. So you can see that these left and right choices are becoming very, very close. So it's getting kind of difficult to decide. So this is where the choice game is kind of hard. But once you get very familiar with the anatomical, landmarks that you want to look for per plate, such as, the way the anterior combo shear looks, this will get progressively easier. So it still looks like to me that, 527 looks best. So let's just say choice 2 matches up. And, let's just go with 2 again with this image. And you could see that Smart is done looping through all of the choice steps. So it started with 200, 100, 30, 10, and then now it, since 10 was the smallest choice step, it has automatically moved to the very next reference template. And you can see that a new one has popped up and it starts over again. So I'm just going to play the choice game really quick. We're going to zoom through this part and then go straight to the midpoint checks. Okay, we're done with the choice game. So the next thing to do is run the midpoint check. So let's do that really quick. So we'll just copy and paste this, but the one thing we have to set is the midpoint argument. So we're going to set that to true. And so basically it'll iterate through all the midpoints of the reference templates we've aligned. And you can see this part is also nice and interactive. So we'll just say, oh, sorry about that. So we'll just compare these two windows, and they look pretty good to me. This looks about right. And so we'll say, yes, we like it. Yeah, that looks about right to me. And so if you don't like the image alignment, and so I will try and make sure we have an example where the image alignment isn't satisfactory. That looks okay. The midpoint game will automatically, once all the midpoints are evaluated, it'll automatically go back into the choice game. So you don't have to run this function another time once if you're dissatisfied. This looks good. Okay. Okay. So I really want to find an example for you guys. So just for the sake of example, I'm going to say that for this one, we don't like it, just for the heck of it. So I'm going to say, no, we don't like the alignment on that one. Okay, let's say that. So you can see that this console will automatically say, play the choice game for your newly added reference plate. And then it'll go into play the choice game. Your reference AP is negative 3.45. So that was the one plate where we answered no to. And then it'll go down the sampling step that we set, or the default sampling step. And so feel free, if your own example images have different Z steps, you can go ahead and set the choice game step progression however you like. So let's play this again. Let's just enter 2. Okay, we're done. So we finished playing the choice game. Let's move on to the next function. So the next function is the brainmorph function. So let's just click on that really quick. And you can see that in the usage, there's only one variable required, or one argument required. Keep saying variable. And that there are a lot of other saving and plotting parameters. So you guys can read about the details of that in the help page. But I just wanted to demonstrate that after the choice game, you can run this brainmorph plotting function, right? And the default is to save your plot as true. For the purposes of this demo, we're going to set that first to false and then take the default later. Because when you set it as false, it will automatically pop up a graphics window that shows you your normalized expansion plot. So this shows you how your data set compares to the anterior-posterior coordinates listed in whole brain and the relative areas of expansion compared to compression of those coordinates. But let's exit out of this. So if we set save plot to true, or we'll just take the default so we don't even have to include this. Let's run it again. you can see that it briefly pops up, but then it will automatically save in our output folder right here. So if you go to RC brain morph, that stands for rostral caudal brain morph, it will automatically show up here. And you can see that the default is to save this image as a TIFF, but you can actually specify the file type that you want here by specifying the file type argument. File type equals, save this as a PNG, and then a JPEG. Oops, syntax error right there. And a JPEG, we can do that pretty easily. So you can see that they pop up in the directory. So that's the brain morph function. Okay. And then the final step after the choice game is to go ahead and take these internal, these aligned reference templates and to interpolate all other atlas plates that are in between the reference templates. So that's done really easily with the interpolate function right here. So let's check out the assignment value that's output from this function. It's also to set up, so you can see a pattern for all of these functions where the output is always to set up. So interpolate all other atlas plates, just for organization, I like to comment. And you can see that the only required argument is setup. And there's also an interpolation method. There's the default is L for linear, but you can also do S for monotonic spline interpolation. If you don't know what that is, you can go ahead and Google it real quick. But to be honest, the default is L because there's really no real difference in the interpolation values. No significant difference because the interpolation is all within the qualitative margin of error. Honestly, the difference in interpolation for one specific plate is probably within 10 Z images of each other, so it really does make a difference what method you want to use, but it's there in case you want to. Okay, so one way we can check whether this is this interpolation has worked is if you use the $ in the console and you go and check out Reggie AP. Okay, so this gives you a list of all of the AP coordinates that are between your first and last image, and it includes the first and last atlas plate. And you can see they're all listed right here, and you can check that everything has been interpolated by going down to Reggie Z and checking out that the interpolate function has aligned all of the Z images in your dataset to these specific plates. Okay, in the next video, we'll go through the actual registration process.